So this is our last scenario of 5C in terms of our objectives. Solving algebraic problems using proportional parts. So far, we've done the side splitter theorem with the parallel lines and how to set those proportions up. We've done the angle bisector theorem, where we look at an angle bisector and set your proportion left over left equals right over right, if you remember that. And then we have another scenario here where we can take a right triangle. It's a right triangle because of the little box that has another altitude. Remember the word altitude, which just means this segment here. And it's also perpendicular to the hypotenuse. Okay? So whenever you have, how many right triangles do you see in that picture? I see 3. I see 2 little ones and then a big one. Do you agree? Okay. So what we're going to look at is 3 different scenarios of how I can take this picture and write 3 different proportions, okay? And we're going to do it in general terms right now with just the letters, and then we'll do some examples that have numbers with them so you see how to do it, okay? So I'm going to do 3 different colors, and if you're a color person, you can do this as well. But I'm going to look at these 3 things. Notice that they all stem, they all kind of connect at that right angle, and they are going to be the 3 different scenarios of how we can write our proportions. So again, you have 3 proportions, and we're going to write all 3 of them. And so basically it's just this. You're literally just going to write 3 different cases. You don't have to do all of them. You can just do the one that, pick the one that you need to solve the problem. You don't have to do all 3. There's just 3 possible if you need them, okay? Let's start with my case, the yellow one, the E. Notice where I'm putting it, okay? So whatever number or letter happens to be in that, on that segment, sometimes it's a number, sometimes it's a letter, but whatever is associated with that yellow line goes there and there. We can do the same thing for the pink one. Whatever number or letter is associated goes there and there. And then what do you think I'm going to do with the D as my 3rd case? Same place, okay? They're actually called geometric means. Not that that matters. I'm never going to ask you that. But in case you are interested, they are called the geometric means, and it's a geometric mean. And it is a geometric mean between 2 things, okay? So let's do one scenario at a time. You ready? E is the geometric mean between B and C. It's that simple. Between B and C. So if it's the one that's kind of in the middle of the triangle, the altitude that's on the inside of the triangle, it just divides that hypotenuse up proportionally, B and C. Again, we're just doing it with letters right now. We'll put numbers in a minute. Yes, sir? That's a great question. No, because you're just going to, when you cross multiply, it doesn't matter the order, right? Great question. Love it. Okay. Does it matter if I put C here or B here, is what he was asking. Does it matter what numbers go where? And I said, no, it doesn't. All right, so that's case 1. I'm going to go ahead and erase it so I don't get confused. And I'm going to look at just A now. When I look at A, I like to draw this arrow, and you'll see why in a minute. Okay, starting at A, going around the hypotenuse. That helps me realize what goes in the other 2 places. It's going to be the part of the hypotenuse that it touches, which is going to be, in this case, just B. And then the other thing is the whole hypotenuse, which, as we're going to describe it, is just B plus C. We just add them together. B plus C. Okay? So make sure you're writing down all of these cases. Again, when we put numbers to it, it might make a little bit more sense. This is just the generic formula, okay, the generic case. All right? Okay. When we look at the other geometric mean, or the other case, I'm just going to erase it so we're stuck with what's left, which in my case is the blue one, which is the D. And again, we're going to draw the arrow, but this time in the other direction, just across it, down to the hypotenuse. What do you think, based on the pattern that we use for our second one, what do you think the pattern, what are we going to put in the other two slots? What do you think? C and then? Very good. Okay, that's exactly right. Okay, those arrows help me, at least me, visualize what goes where. If you don't want to do the arrows, you don't have to. But again, it's just the part of the hypotenuse it touches, and then the whole hypotenuse. Are we okay so far with just the general formulas? Okay. So let's put it into practice. What example number are we on your 5C notes? Is this example 4? I believe so, right? So this right here is going to be example 4. And we have, we'll make it a little bit bigger for those of you in the back so you can see it a little bit better. Oh, that's not going to work, is it? Because it messes up the size of the triangle. Sorry, we're going to leave it the way it is. So here's example 4, Mo. You want to copy this one down for me, sweetheart? Notice it has some numbers in it this time. All right. So again, I'm just going to highlight these to show you that these are my 3 possible things that go, the other 3 geometric means, right? So I'm going to set up, how come I'm only going to set up 2 equations here, or 2 proportions? Only 2 of the 3 things, 2 of the 3 possibilities are labeled. Do you agree? This guy here isn't even have a label to it. It has a number, doesn't have a letter, doesn't have anything. So we're not even going to use it. Is that okay? The first one happens to be a letter, which is a y, a variable. That's fine. Sometimes there's numbers there. I don't care if there's a variable or a number. Whatever is listed on that altitude goes here and here. Sometimes it's a variable, sometimes it's not. The other possible geometric mean is the x. Again, it's a coincidence that they're both variables, okay? They don't have to be. They could be numbers. I think on one of your practices it is a number, so just be careful. Any questions about that so far? All right, then let's just set it up. Look at your example that you just copied down, the formula, and look for the middle one. In our case, in this example, the y. What is it the geometric mean between? What numbers or what variables go in the other 2 spots? 12 and 4. Perfect. I agree with you. 12 and 4. Good. Then how about in the other one? When we're looking at the x, 4 and, which is just what? Right, so between 4 and 16. Any questions about where the 16 came from? So 16 came from because, remember, when we're doing the geometric mean on one of the sides, it's the part that's closest to, and then the whole thing. The whole thing is 12 plus 4, which is 16. Because this one is the middle, and it just goes between them. That's what the formula tells me to do, okay? Any other questions? Can we set them up okay? Because your directions on your quiz next class are going to say, write the proportion and solve. We have the proportions written. I'm going to pause it. I want you to solve it. I agree. Y times y is y squared. What's 12 times 4? No. 12 times 4 is? 48. Now the problem, Mo, I need you to sit down for the 3rd time today. I understand, but you've been out of your seat 3 times already today. We have a shortened period. I don't have a lot of time not a fluff time today because of the ice. So how do I solve this for y? 48 equals y squared, square root of both sides. Very good. Now, the square root of 48 is not a perfect square, but you have calculators. Round maybe to the nearest tenth. What did you get? 6.9 maybe? 6.9? Does that sound right? Double check my math. And I'm okay if you round it to the nearest tenth, okay? That's fine with me. I could ask you to reduce the radical by pulling out perfect squares if you're interested. Otherwise, you can just round to the nearest tenth. Let's do the other side. X times x is, okay, 16 times 4 is, and then when we square root these two sides, I get an exact number of 8. Okay? How do we feel? I don't think it's the solving of the proportions that's the hard part. It's that there's just so many ways to set them up. Okay? If you go back and look at your angle bisector questions, look at problem 7 and 8 on here. Do you remember how to set those up? Left over left equals right over right. Remember that? That's how you set those up. You need to know all the different ways. Okay? So what I'm going to do is I'm going to pause the recording here for just a second. Remember how I said you had to have that blank piece of paper out? Okay. The blank piece of paper is going to, for you to practice these two problems. Okay? You also have another 2 word problems that we're going to practice as well. The word problems is a punch on your passport, and this one is a punch. Okay? You can do it on whatever piece of paper you want as long as I can see your proportion, how you solved it, and your answers. Okay? So I'm going to leave these up here for right now. Pause the recording. This is one punch. Remember all the different punches. You need to make sure that if you were not in flex yesterday, that you do the dry erase packet, which is your first punch, because you never did it. Okay, all of these are going to be a grade, by the way, before you take your quiz. So, go ahead and get started. As I'm walking around, I want to see something that I'm not seeing. On the left-hand side, this is a mistake, and I see a lot of people who have it. That is a mistake. Because B is not one of the 3 things that are coming out. Do you agree? What number goes in that special place? 5. Okay? So make sure that when you're setting this problem up, that 5 goes there. Okay? That's your hint.